There is a chapter of Cold War survival technology that never made it into mainstream military manuals. It wasn't a classified nuclear device or a secret aircraft. It was something far more humble, something designed not for weapons, but for human endurance. Soldiers stationed in remote northern bases, radar outposts and early warning stations used a field-made heat reflector that kept them warm in temperatures where standard military gear failed. Veterans talked about it quietly, usually long after retirement, because it wasn't officially endorsed. It solved a problem the military struggled with for decades: how to conserve body heat efficiently without bulky fuel systems or electrically powered gear. And the real reason it was kept in the shadows is simple. It made some standard-issue equipment almost obsolete. Stay with this next minute, because the ingenuity behind this forgotten reflector reveals how Cold War fieldcraft wasn't just about espionage and electronics. It was about survival in some of the harshest climates on Earth. Understanding how it worked not only gives us a deeper look at Cold War engineering, but also offers a practical skill that modern survivalists can use with materials already on hand. How Cold War engineers rediscovered a principle older than warfare itself. During the height of the Cold War, many northern installations operated in brutal conditions. Temperatures dropped to levels where steel tools froze to bare hands, and frostbite set in before a full sentence could be spoken. Standard military tents, wool layers, and fuel-fired stoves often fell short. What engineers eventually turned to was not a modern invention, but a scientific principle understood by ancient metallurgists: radiant heat reflection. Instead of trying to heat the entire airspace inside a shelter, they focused on capturing and reflecting radiant heat back toward the body or group. The breakthrough came from combining thin metallic layers with insulating layers of fabric, creating a sheet that could reflect more than 90% of emitted body heat. Early versions were tested for radome crews and Arctic patrol teams. When set up behind a cot, hung next to a sleeping bag, or placed as a backdrop near a small stove, it amplified warmth dramatically. What made it controversial is that this simple sheet performed nearly as well as expensive heating units that required constant fuel supply. In isolated outposts where supply planes sometimes didn't arrive for weeks, the reflector became a quiet lifesaver. The effective version wasn't the shiny plastic survival blanket people know today. Those tear easily, make noise, and don't perform well once creased or punctured. The Cold War reflector was rugged. It combined metal foil, often scavenged from radio repair packaging, food storage sheets, or signal equipment, with canvas, wool, or treated paperboard. Engineers bonded or stitched the metallic layer to the insulating layer so the reflector remained flexible without tearing. A sturdy reflector could be rolled, packed, folded, and hung repeatedly without losing performance. When placed on the inside wall of a tent or behind a heat source, it created a directional heat effect that allowed soldiers to sleep comfortably in temperatures far below freezing. Its effectiveness was such that teams frequently kept one reflector near their bunks and a second near their workstations. Because it required so few materials, it borrowed heavily from local improvisation. In Greenland installations, men used foil from shipping crates. In Alaska, crews reinforced foil with sealskin parchment or wax canvas. What mattered most was the reflective surface facing inward and the insulating surface trapping the redirected heat. Early Cold War heating systems consumed kerosene at a rate that made supply chains unstable. Some units needed daily fuel deliveries. When storms or political tensions delayed resupply flights, bases found themselves rationing heat. Soldiers who relied solely on mechanical heating often slept in sub-zero conditions that damaged equipment and weakened morale. The reflector, on the other hand, required no energy. It reduced fuel use dramatically by capturing radiant heat that would otherwise be lost to the walls of a tent or bunker. When paired with even a small stove or candle lantern, it created a microclimate of survivable warmth. Crews recorded interior temperature increases of 15 to 20 degrees in some cases. The reflector also performed silently, didn't produce any smoke, and, well, required no maintenance at all. Its reliability is what made it quietly favoured, even though it never became an official piece of equipment. So, here's how you can build the same heat reflector today with just some simple materials. The goal is to pair a heat-reflective layer with a durable backing that traps air. Heavy-duty aluminum foil works for the reflective surface, but honestly, it's the backing that really makes it effective. A wool blanket, thick canvas, or even corrugated cardboard provides the insulating structure you need. First, cut the backing material to size. Then, spread foil across one side, making sure to keep the reflective face outward. You can use glue, stitching, or staples, depending on what materials you've chosen. Once it's all attached, the sheet can be hung like a wall panel, or just propped behind a heat source. And if you're using it near a fire or stove, always maintain proper distance to avoid scorching the backing. Now, a practical survival application worth knowing is creating a heat corner inside your shelter. You simply place one reflector behind your sleeping area and another beside it, so they form a 90-degree angled surface. When your body radiates heat, these reflectors, well, they redirect it right back toward you, instead of just letting it dissipate into the cold. This setup only takes a few minutes, but honestly, it can transform the usable warmth inside a tent. Another application is enhancing a camp stove. When cooking or heating water, place the reflector behind the stove so heat isn't lost outward, but directed back into the camp area. This reflector represents the side of Cold War engineering that rarely gets celebrated. The solutions rooted in physics, necessity and fieldcraft rather than electronics and weapons. It kept people alive in places where temperatures could break machinery and morale. It also demonstrates how a simple, low-cost tool can outperform complex systems. For modern survivalists, campers, and preparedness-minded individuals, this reflector remains one of the most effective ways to boost warmth without fuel. For history fans, it's a reminder that the Cold War wasn't fought only in intelligence rooms, but in remote stations where ingenuity mattered just as much as strategy. If you enjoy deep dives into forgotten technologies that still work today, subscribe to In the Beginning and share this guide with others who appreciate the kind of history that deserves to be kept alive.